Yeah, you can go ahead and start now.
Okay. Good afternoon. I am Erika Buscardo. This is the third research seminar in this year series, organized by myself and my colleague Eraldo Matricardi within the postgraduate program of Forest Sciences here at the University of Brasília. These seminars are concerned with environmental changes, challenges that humanity faces, and how forest sciences could contribute to solution. In the first seminar, we saw the role of forest in the carbon balance by John Grace of the University of Edinburgh, and the use of remote sensing for the quantification of carbon in Amazonia by Luis Aragão at UnB. In the second one, we had two talks on global changes. The first one on global change and sustainable development in Amazonia by Mark Cochrane of the University of Maryland, and the second one on climate change by Paulo Artacho at the University of São Paulo. Today, we have two talks by Professor Davis Cole of Michigan State University and Carlos Eduardo Young, Cadu, at the University Federal of Rio de Janeiro. And they will speak us about ecosystem services and financing mechanisms. On the panel, we have Enrique Chaves and Eraldo Matricardi of the University of Brasília and Laszlo Nagy of the University of Campinas. I would like, first of all, to thank our speakers and the members of the panel for kindly accepting our invitation. And I shall now introduce our speakers. So, David Skoll is professor of forestry. His research focuses on the relationship between land use change, climate change, and the use of geographical information for sustainable development and natural resource management. The current focus of his work is climate change mitigation and adaptation in international development, with a focus on carbon measurement and accounting for REDD+. He has more than 25 years of experience with research on forestry and carbon. He was instrumental in constructing the first numerical carbon accounting model and has been spearheading the integration of satellite remote sensing into carbon accounting models. He was formally recognized for his climate change research as an official member of the United Nations Intergovernmental Panel on Climate Change that shared the Nobel Peace Prize in 2007. He is now active in the emerging carbon financial markets and application of his research to carbon sequestration and climate change mitigation project in developing countries. Carlos Eduardo Young is professor of economics and researcher of the National Institute of Science and Technology in Public Policies, Strategies and Development, and collaborating professor of the Environmental Science Program of the State University of Mato Grosso and Environmental Sciences and Sustainability in Amazonia. He has an extensive experience in teaching and research in the area of economics, with emphasis on economics of environment and natural resources, working mainly on environmental policy, assessment of ecosystem services, determinants of deforestation, payment for environmental services, economic aspects related to climate change and pollution, environmental macroeconomy, and green accounting. He is the coordinator of the group of environmental economics and sustainable development. I would like to remind you all that we are live on YouTube, that the event will last 2 hours. We shall have first the talk by David, entitled Linking Tropical Forest Carbon, Climate Change Mitigation and Economic Development, the Carbon to Markets Ecosystem Service Mode. And following this talk, we will have Carlos Eduardo Young, that will speak about, who will speak about financing mechanisms through to protect native vegetation and conserve the biodiversity and ecosystem services in Brazil. After the presentations, there will be a panel discussion session, including answering questions that we will receive from all those that are following us on YouTube. Now I give the floor to you, David. You can go ahead.
All right. Thank you very much. Thank you very much, Erica. And thank you, everybody at the University of Brasília, for inviting me to this, this seminar. I'm going to share my screen now and get started. All right, it should be coming soon, I hope. Here we go. Okay. Oh. There, that was a preview. All right. Good afternoon. Bom dia. Tudo bem? And so again, thank you for having me here. I'm going to talk about some new work that we're doing at Michigan State University that relates to understanding climate change by looking at land use change, land cover change, particularly on forests and tree-based systems, linking forest carbon, climate change mitigation, and economic development together through this model that we've developed at the Michigan State University. It's a development model called Carbon to Markets, which you'll hear more about. I'm a director of a unit at Michigan State University called the Global Observatory for Ecosystem Services. And the purpose of that unit is to do research and engage the policy process related to ecosystem services through Earth observations and quantification and measurements of ecosystem services, including ecosystem services valuation. We're a team of biophysical, ecology, forestry type scientists, as well as social scientists, economists, and the like. And it's a pleasure to be on this panel with Kadu, who I think we have complementary presentations in store for you on the subject of ecosystem services. So without further ado, let me get started. Just as a quick review for people who may not be completely familiar with this concept of ecosystem services, I present this. Ecosystem services are the benefits that we receive from ecological systems and the processes of ecological system. This cute diagram presents some of the kinds of things that we are talking about. On the one hand, we have provisioning services like provisioning of food and fuel and fiber, wood and other products from ecosystems. There's also a regulatory function of ecosystem services like carbon sequestration. The next slide will get into more of this, but I wanted to highlight that what I'll be focusing in on today is the ecosystem services related to carbon sequestration, the role of carbon sequestration in climate regulation, and also at the same time, provision of food, fiber, and fuel to support livelihoods of local people, primarily in rural areas in developing countries. So just a quick review of types of ecosystem services. We commonly think of three major types. The first are supporting services. These are things that ecosystems do, and we're talking about tree-based or forest systems that supply the materials that are necessary for the production of other ecosystem services. For instance, I highlight net primary productivity because net primary productivity is the ecosystem process that sequesters carbon or exchanges carbon dioxide with the atmosphere with plant growth and ecosystem production. This is a supporting service that supports the production of wood and fuel and also regulating climate and participating in the carbon cycles. So the provisioning services include, as shown on the table below, the ones that I'll be referring to: climate regulation, disturbance regulation, biological regulation, in other words, enhancing biodiversity, water regulation, maintaining water resources and soil moisture content and so forth. In terms of the provision, in terms of other services, there are regulating services that are the benefits that are obtained from the processes, such as climate regulation. So these bulleted, red bulleted services are the ones that I'm going to focus in on in the discussion of how carbon and carbon sequestration in tree-based systems provides ecosystem services and potential value chains to local farmers that use tree-based systems in their activities at the farm or in forests. So if we want to look at a functional model of ecosystem services, this is the way I see how it unfolds or is laid out with respect to tropical forests and the role tropical forests play in providing benefits to humans, individual farmers, as well as society at large. So on the, if I can use the, let's see, yes, you can see this. So really we have two main aspects of ecosystem services. There are the environment, there's the environment component, and then there's the social and economic systems that are beneficiaries of the environmental functions of ecosystem services. And as Robert Costanza likes to point out, this division, this boundary line right here between the two, between the environment and social, is often referred to as the production boundary. This is the boundary in which the ecosystem services are converted to goods and benefits that have actual value to individuals, to communities, to national country level societal benefits. So the supporting services are first the biophysical structure or processes. This is the basic ecological function of a woodland habitat or net primary productivity in forests that create wood by sequestering or removing carbon dioxide from the atmosphere. These systems that are produced, these biological systems that are full of biomass and rich in carbon, have a function. They can regulate the climate system by maintaining the carbon stored in wood, and other sorts of basic functions that relate to the processes in those ecosystems. They produce the final services, which may be regulatory or provisional. The services can include water retention, flood protection, harvestable products, food products, and all sorts of other kinds of final services. Then, as those products are converted for human benefit, we go across this production boundary, and the products provide benefits to humans in the form of valuable, in other words, goods and services that can actually be brought into the economic domain through value chains and have value. There's a common phrase that's used by the ecosystems marketplace folks that talks about the market value of ecosystem services in a conservation context. The phrase is, I think, very kind of cute, but also very useful. We conserve what we value. And so the valuation of this long chain of ecosystem services and the provision of ecosystem services for human benefits is important as well. So with that, let's talk about two of the biggest problems that confront society in the world today, climate change and development. And when I speak of development, I'm oftentimes speaking in terms of poverty alleviation. So two of the greatest challenges confronting peace and prosperity in the world today are climate change and poverty. But I think we can look to models that twin climate change mitigation and poverty alleviation. So on the one hand, tropical forest loss and degradation is actually the second most important emission source of greenhouse gases to the atmosphere after fossil fuel combustion. But deforestation and forest degradation also are larger contributors of greenhouse gas emissions than the entire transport sector. And over a long historical perspective, last 200 years, the emissions of greenhouse gases to the atmosphere from forest and other ecosystem conversion is approximately equal to the fossil fuel contribution over the long term. From a scientific point of view, this is really important because the forcing on atmospheric increase in carbon and the oceans is a function of the long-term contribution of CO2 to the atmosphere. And their ecosystems and forests have been important contributors alongside fossil fuels. Degradation within forests is becoming much more important. And in fact, more important perhaps in many places of the world than deforestation alone. So when we think about what's happening in terms of forests and tree-based systems, it's not just the question of outright loss and conversion of these systems, but it's also a question of how they're being degraded. And I'll talk a little bit more about that a little bit later with respect to the Amazon, some of the work I did with Geraldo Matricardi and his colleagues at the University of Brasília on the Amazon. Now, forest ecosystem services, on the other hand, play an incredibly important role in regulating climate at the same time. And these are myriad kinds of services that involve reducing degradation that can be seen in forest landscape restoration. Forest landscape restoration, or FLR, is becoming incredibly important as a management and policy intervention, utilizing the ecosystem services of carbon sequestration to mitigate climate change, to work against the problem of climate change. Another example is agroforestry in trees outside of forests. So in addition to the really incredible importance of degradation that the science community is now focusing on, the question of agroforestry and other systems that operate in trees outside of forests is also becoming important. So it's not just the dense, high biomass, high carbon forests of the Amazon, the Congo Basin, Indonesia, but also large land areas in which tree-based systems can play an important role in terms of ecosystem services related to carbon, climate regulation, and a host of other kinds of services in these tree-based systems like water retention and biodiversity. So in terms of forest management, what's interesting about tree-based systems and forests is that emission reduction and carbon sequestration can take place. So if you think about policies and interventions for energy, the energy policies will only reduce future emissions. Unlike energy policy, however, forest and tree-based management can both reduce future emissions, but also through sequestration, recover carbon dioxide that's currently in the atmosphere. So on the development side, it's important to realize that we do have another important issue confronting human society. More than 1 billion people live in extreme poverty of less than $1 a day. These livelihoods depend on the consumption and sale of natural products. Many of these agriculture and forestry-dependent communities around the world, particularly developing countries, are very much dependent on natural ecosystem services. About 2/3, however, live in ecologically vulnerable and marginally productive landscapes. Tree-based systems for ecosystem services, such as agroforestry, can provide both mitigation and adaptation benefits. So again, as we recognize from the ecosystem services on the carbon side, the dual purpose or the dual role they play in emission reductions and sequestration, they're also on the development side have a dual role for both mitigation of climate change and adaptation, providing enhanced measures for adapting to climate change. And in particular, the importance of tree-based systems is that they can also support livelihoods and thus have a real economic basis and importance attached to them as well. So the usual face of forest carbon is about deforestation and forest degradation. In fact, the usual face until recently has been really emphasis on loss of forest, the deforestation of forests. Now we see a much more important, an increased emphasis and focus on the degradation of forests. That is the changes of carbon and the changes of the structure within forests. And I point out two papers that just have come out in the last 2 years, or last year actually, that are really highlighting the importance of degradation of forests in the Brazilian Amazon. One that was published in Science recently by Araldo, myself, and our team. And then another one that followed from another team that published in Nature that actually quantified the carbon loss of degradation and showed that it's very important in terms of carbon fluxes. Now, these are incredibly important new developments. The work on closed forests is going forward. The new thinking is about looking at degradation, and these have been incredibly important for obvious reasons. But that's not all there is to the story. We're working now a lot on biomass outside of the dense forest. What's happening there in woodlands, such as, for instance, the Cerrado or the Chaco ecosystems in South America, the Miombo forest of East and Southern Africa, extensive forested woodlands around Southern Africa, the semi-arid savannas of West Africa, and other open ecosystems in the tropics and subtropics. There's not been much work in these systems, yet they can be incredibly important, as I'll show in a minute. The other side of this is to look at regeneration systems on managed landscapes. Here I'm talking about, for instance, agroforestry systems that may be outside the dense forests, or widely spaced trees associated with agriculture, or what we often refer to as trees outside of forests, plantations and orchards, and also industrial forests. Forest landscape restoration projects where forests are being established to restore degraded landscapes. And what some folks are referring to as multifunctional agricultural systems, which are mixed woody perennial and annual, somewhat like agroforestry systems around the world. So these two areas are really understudied, but yet profoundly have important roles because the ecosystem services offered through these systems touches many, many more people's lives because many, many more people are dependent for their livelihoods on these kinds of systems. So let me give you an example from savannas, woodlands, and agricultural systems, and what we're doing with some research there to find some solutions. This is a very high-resolution imagery from commercial satellite WorldView that shows a landscape in West Africa that is on the margin of a dense savanna woodland in the bottom, and then trees outside of forests and sparse savanna woodlands with many widely scattered trees, including trees on farms. So you can see all this in this kind of picture. Now, recently, the science community is taking advantage of machine learning algorithms and a lot of other computational processes in remote sensing to be able to quantify the tree crowns of these savannas and dense woodland systems, as well as the trees outside of forests. So in this image, what we've done is we've converted the image to a map of tree crowns from which we can quantify the canopy area and also the cover density. And I'm going to also show you how we can also use these kinds of remote sensing techniques to quantify carbon and biomass in these systems. So this is a zoom in to show what that map looks like, a little bit closer detail. You'll notice there's some offset between the georeferencing between the worldview image and the post-processed canopy maps. That's just a shift that can be adjusted, and it's not adjusted in this image. The canopy data come from Martin Brandt's group at the University of Copenhagen, who's doing some really spectacular work on mapping individual tree cover using machine learning process. So here's some work that we've done in savanna systems and woodland systems. On the left, you see very high resolution data from worldview data sets, 0.5 meter resolution, where individual trees and tree crowns can be seen very clearly as objects. And then on the right is, I'll give you a preview. This is the resulting product that we're aiming to get. And this is a map of individual tree biomass based on a crown-based allometric scaling model of tree carbon. So I'm going to talk a little bit about how we've developed some allometric scaling models that use standard allometry. So it's very compatible with standard methodologies for RED and other kinds of work. It's IPCC compliant, and it also links into the way foresters in many countries around the world have traditionally measured biomass in trees using allometric scaling models. So there, the circles represent the detection of a tree crown, and the color coding from light to dark is relative to the biomass that is computed. So it begins with field work. We go into the field and make some basic field-based allometric measurements, primarily classical, diameter at breast height. And this picture shows some folks standing around a tree while somebody's measuring the diameter of that tree. This happens to be an isolated tree, a kind of tree outside a forest. We also invoke the traditional kind of standard destructive sampling, developing allometric measurements that give us more detailed information on the mass of the tree, the volume of the tree, above ground and below ground to understand root to shoot ratios, and then gather all the other necessary carbon and biomass related parameters to build the standard allometric equation for these kind of trees in this system. This happens to be activities in Africa. I'll show an analog for the Amazon or the Cerrado later. And then we also capture a crown projected area, which is just the area of the crown as it's projected on the ground. You can see the shadow on the ground, giving you some idea of what the crown projected area looks like. And we measure this using standard foresters' techniques of measuring the long diameter and the perpendicular diameter and computing the area based on the formula for an ellipsoid. So this gives us the ground measurements to calibrate a remote sensing analysis. Now, what's the problem with remote sensing? The remote sensing analysis cannot see the dBH. Most equations, allometric equations, rely on dBH or maybe height. Now, there's some LiDAR work that shows you might be able to get the heights, but the dBH has heretofore been a ground-based measurement. What the satellite sees is simply the crown area. So we're measuring the crown area to calibrate the satellite data and produce a model as shown here. The diagram on the top shows the result of a simple logarithmic, a simple polynomial model, allometric scaling model that showing the relationship between measurements of field dBH and remote sensing measurements of the crown projected area. And the relationship for this model in West Africa is pretty good, R-square of almost 0.9. And it is significant. The graph on the bottom just shows the validation experiment that's been done where the field measurement of dBH and the predicted measurement of dBH coming from the model shows up in that diagram there. Fairly good kind of relationship. So the game here is to get a model that can allow us to take this crown projected area seen from satellites, convert it to the dBH that you would ordinarily measure in the field, and then you can use the dBH in an ordinary allometric equation to compute biomass. And so when you do that, you apply the crown projected area to derive dBH, use the dBH in a locally derived allometric model, preferably one that's developed through destructive sampling. You get this kind of map across the landscape where you have individual trees being mapped with their crowns. Crown area is then estimated, as well as the carbon stocks for these forests. This happens to be the woodland systems that are part of a production agriculture system. So this is a very important kind of map for local livelihoods kind of work. Right? And in fact, this experiment has been done in a similar case in acacia woodlands in Africa. And this is what I would call a sparse Cerrado analog. And so you see on the right side, a very sparse acacia woodland being mapped, each circle being a tree, and a carbon value is attached to it. On the left, it's a much more dense case. And now this is useful because we have developed this carbon to markets model. What is the carbon to markets model? The carbon to markets model is something that says that adoption of agroforestry and use of trees in farming systems, the use of trees, especially in places where there are annual production of sorghum or millet or maize, some of these other kind of annual crops, at a much lower economic value than what you could get from neem or shea butter or jatropha from woody perennials. These kind of systems of agroforestry have been very difficult to get adopted because there are obstacles. There are economic obstacles to their adoption, primarily the delayed benefits problem, that local farmers, local land managers can't afford to take land out of production for a long period of time to wait for the trees to grow, mature, and begin to produce their marketable product. So what the carbon to markets model says, if we can measure the biomass and the biomass accumulation, even before a fruit or a product is produced, then we can engage the carbon financial markets with a different value chain than the natural products, a carbon value chain that could come immediately, and then that would offset the delayed benefits problem for a period of time while the farmers can establish their woody tree systems. And here we did a simple model of a simple system in which the cereal production, the annual production, would have been only about $240 per year per hectare. But then if you add into it the woody perennials like shea, jatropha, neem, and the carbon market benefits, you increase the revenues to about $1,800 US per year, per farmer, per family, per household. That's double the annual income for those living at the ethical poverty level of $2.40 a day. Now, what's interesting, though, is that the carbon financial return isn't as big as some of the others, particularly neem in this case. But that's not the point. The point is that it allows enough, about 20%, that enables the farmers a buffer, enough of a return that they would reduce their risk and engage in a establishment of a long-term growth and production of trees. And so then what happens is a larger system kicks in, a system that has higher values, and they reinforce the carbon values because with higher returns from neem, jatropha, and shea, you enhance the permanence of the carbon, which is absolutely necessary for climate change mitigation. It needs to be permanent. And so that's the dual reinforcing value chains of carbon and natural products, and why we call it carbon to markets. It means really two value chains for the market, as well as getting it to markets. So I'll end with this, some emerging observations and thoughts. Some estimates are coming out now. There's a lot of discussion about this, that there are large amounts of carbon sequestration already occurring in many of these managed ecosystems around the world, in India, in Southeast Asia, in Africa, and in Latin America. For example, a study of 64 rural places in Africa showed that while forests were declining by 50%, the agricultural area was increasing, of course, as a result, but the proportion of agricultural land under tree cover increased 22%. So tree cover is increasing even in these agricultural areas. And one estimate that would say between 2000 and 2010, there's about a 2% increase in tree cover on agricultural lands globally. For instance, in Africa, 36% of Africa's land area had an increase in woody cover between 1992 and 2011. This is from Brandt's lab and University of Copenhagen. The annual expansion of sparse tree cover is storing perhaps an additional 740 million metric tons of carbon dioxide per year on a global basis. That's almost 1 billion metric tons on a global basis. And then there's this interesting observation that we're looking at in more detail and from a more theoretical basis. Brandt and his colleagues have observed that there is elevated tree biomass around village areas compared to stocks in the natural savannas and woodlands. This seems to be a case in India and Bangladesh and in some other places as well. And this is putting forward a mechanism that we're postulating and we're looking at deeper. While changing climate patterns are influencing increased tree productivity, NPP, farmers are also actively promoting enhanced tree biomass to capture the direct and the indirect benefits of tree-based ecosystem services, especially from agroforestry. These are both market and non-market benefits. Market benefits like the production of neem for sale in a market, but also the production of fodder for local livestock, or the production of services that retain soil moisture, which are not market-based. And so there's some sense, there's at least a hypothesis that farmers know this, and they're engaging in the promotion of woody cover. Now, if this is true and widespread, that's interesting in its own right, but it's also interesting from a policy point of view because it means that an intervention to increase woody biomass for carbon sequestration could be leveraged against already existing traditional practices. That means it can go to scale. So in conclusion, I want to just bring it down to 4 points. We can map it, we can measure it, it can go to scale, and it has value. So we can map and we can detect and map sparse tree cover over large areas in detail using these remote sensing methods that I mentioned. We can measure the carbon using remote sensing, using allometric scaling models that are linking the crown observations to traditional DBH and other allometric parameters. The carbon ecosystem services that we get from these can form the basis of a multifunctional model that supports climate change mitigation and livelihoods. This is the carbon to markets dual value chain model. And the valuation of carbon ecosystem services, that's the valuation of the ecosystem services, not the description of them. The valuation of them can support new market or investment models, both at the local level, community level, and also larger scales. The interesting thing here is that adaptation then is also naturally linked. So we can broaden the discussion from just climate mitigation to adaptation. And because it seems that farmers actively engage ecosystem services, either directly or indirectly, we can go to scale by leveraging traditional practice. So that's some insights that we're trying to look harder at in our lab, and I think it has application to sparse woody systems all over the world, including the Cerrado and the Cerdao, the Chaco in Latin America. So that's what's next for us. Okay, thank you.
Thank you, David. Very inspiring talk. We give now the word to Professor Young. Kadu, you can tell please us about the financing mechanism to protect ecosystem services in Brazil. And we pass afterwards to the discussion.
Mute. Good afternoon. Thank you very much for the invitation. And it is a big pleasure and the opportunity to talk to David, which has been a quite interesting talk and very, in some sense, complementary to what they're going to say. Because what David showed was the importance of ecosystem services, how to measure them, and how much difference they can make, especially for poor agricultural families. And there is a potential for that. But on the other hand, there is a big problem in transforming values into prices. And David was very happy in the way he presented the importance of these values. But in order to these things to happen, in economic terms, certain conditions are required too. And unfortunately, there is a big gap, especially in the developing world, between what is the potential of these instruments, carbon to markets and others, and the reality that we face. So my talk will be mostly on presenting solutions for that. I mean, I could be talking about the problems. I suppose that all of us are pretty aware of the problems of environmental policy and forest preservation in Brazil at the present moment. And I will not try to spend our time into, discussing things that we already know. I'll try to present potential solutions. So the biggest reference for my talk is a recently published paper at Ecosystem Services. Professor Bianca Castro and myself, we published the results of a research that we've been carried out for some time on the economics of ecosystem conservation and biodiversity conservation. There is an additional paper, this is more for the forest science students that are not very much aware of the economics of forest preservation. This is a recently published paper at the Oxford University Press Encyclopedia of Environmental Sciences on the idea of environmental, economical and environmental aspects of tropical rainforests. And mostly for the Brazilians, these are two published papers in Portuguese. The first one is adding to what they've just said about valuation of ecosystem services. This is a very simple paper, this 2015 Roteiro para Valoração. This is a document we produced for Fundação Grupo Boticário in order to present the basics of valuation of protected areas. This is mostly for non-economists. So this is an invitation for science students to get who wants to know more. And the second one is a big research we produced about the economic values of the Brazilian protected areas. And David, if someone reads Portuguese in your group, I would suggest you to take a look on that, because it has estimates of 5 different issues concerning the forest. One of them is carbon. How much carbon emissions have been avoided by the fact that Brazil has created protected areas. There's another one on extractivism, on timber and non-timber forest products. There's another one on issues that I'll be talking about, water and soil erosion. Another one on tourism, and another one on fiscal transfers. I'll be talking about it. And this gives the numbers for the large figures, the potential that we have. But the paper that I'll be discussing today is more specific on how to move ahead. And the idea is that there are possibilities, and David has presented a very interesting example of one of these financial mechanisms that can be a tool for conservation of biodiversity and associated ecosystem services. Just very important to people understand that from the environmental economics perspective, we are so far very far from reaching a proper measurement of the value of biodiversity in itself. So what mostly we can do is to value ecosystem services that are usually associated with biodiversity conservation. For example, carbon. So the forest has carbon. The forest has timber and non-timber forest products. The forest attracts tourists and things like that. And the forest has biodiversity. We can't measure biodiversity, but we can measure all the others. So that's what we're trying to do at the present moment. Just making a very brief summary of what we're going to be presenting to you. We carry out a research. We selected 25 different mechanisms that could be applied into the Brazilian case. We shortlisted 5 of them, which are the ecological transfer, fiscal transfers, what we call the green ICMS, environmental reserve quotas, the CRA, CRA, payments for ecosystem services, environmental services, tourism concessions, and forest concessions. Our estimates is that have the potential to reduce the financial gap that we biodiversity conservation in approximately $1 billion annually. It's a lot. It's a really, really big number. And most of these instruments, not all of them, they can involve also the private sector and creating new businesses, but up to specific conditions. And we have very important problems that are obstacles that are, for the moment, keeping all these possibilities, let's say, wasted opportunities, because from the current situation, due to these problems of weak public management capacity, institutional uncertainties, and political to environmental policies and instruments, they make these instruments not feasible to operate at large scale. So this is the main subject that we'll be talking today. First of all, I believe that everybody is aware that we need resources for biodiversity conservation and forest conservation. And forest, I mean, talk all of the native vegetation kinds of types of forests. I mean, we have this bias of thinking that only, densely wooded vegetation is forest, while we have very important vegetation which has very little carbon, by the way, but they are important too. So they require resources, and we need to promote these resources. And at the present moment, there is a big gap between what we need in terms of resources, financial, human, technical, and the capacity of raising these resources. And the situation has worsened considerably in Brazil, not only in the last 2 or 3 years, but I mean, it has been for quite a while. The situation is getting worse every year, and the worsening is accelerating, but the trend is negative for some time. So we need to find a way to go ahead. And one of these possibilities is try to get new sources of funding. And this is what we'll be talking about. So we need to reduce the strong dependence on public funding and international cooperation. We need to incorporate new ways to obtain resources for conservation. It has to do with partnerships, market-based instruments, etc. But all of these instruments require a very active presence of the state. It is a myth. It's completely wrong to say that a carbon market is something that goes outside governments. It only exists because there is a government. And the only reason why someone buys a carbon title is that this person, this company, needs to follow the regulation of someone else. A carbon credit nobody does anything with a carbon credit. The only reason is that there is a policy that is enforced by some government that demand that this economic agent to purchase this. While you have these voluntary carbon markets trying to go ahead, our experience in Brazil is that it has been extremely limited. What we need is regulation. And because we didn't go ahead after the Kyoto Protocol, there is a vacuum on this situation. It explains why there's so many important possibilities that has so much potential to reduce carbon emissions have not been used. And not only on that, we also have we are under a serious water crisis problem that is related to the lack of protection of forests. And we could improve our water regulation capacity through forest conservation, reforestation, but we don't have the incentives to do so. There is a lot of advance on the theory of biodiversity finance. The UNDP, the United Nations Development Program, has sponsored this big initiative called BioFin. And it has produced a very interesting material for, it's worldwide, it's a very interesting approach to integrate finance and conservation issues. And the idea is that financial and economic decisions are important for conservation. Even though they are limited, they can't capture all of the values associated with this. But it is possible that they can contribute to protection and restoration of natural habitats. And also, and it has been presented before me, how this can improve issues such as social justice and ethical principles. We also believe that it is important to have this policy mix concept, that we don't have only one single policy to deal with all of the problems. We have to combine very different instruments. So when you're talking about biodiversity conservation, finance, we are also talking about market-based instruments. We're also talking about command and control and technology. And there are so many different public policies issues concerning the same subject that we need to make a mix of them in the right direction. So we should avoid this idea of the silver bullet that's going to solve all of the problems. So we're talking about one of these dimensions that can improve, which is financing on that. There are different kinds of mechanisms and instruments that have economic basis and that are able to encourage forest protection. Grant and transfers, for example, without repayments. For example, Bolsa Floresta in Amazonas state is a big example of that. It's a grant, there's no repayment back. Just this is something that most of the voluntary market is based on this idea. It's a grant that you do something and you're going to receive some general positive thing for the global environment in exchange. But we also have this debt and equity instruments. It's, well, in the past they used called the debt for nature's swaps. It's a possibility, but it's more related to countries with very limited economic resources. Risk management is increasing as a way to introduce issues on relating to environmental protection. Fiscal instruments, specifically the Piguvian taxes and things like that. I'll talk about one of these specific issues today, which is the ICMS ecológico, the green ICMS. It's a Brazilian innovation that has been for a while now, 20 years in operation. It has been very successful. It's been successful in achieving environmental goals. Market instruments, as already presented early on, and regulatory instruments that are also important. So we should always think, when you're talking about this economics for forest conservation, we talk about a set of possibilities. And then we have to understand the specific context of the problem that we're dealing with in order to select which one is the best one, that's the best fit for the problem we're trying to approach. And in order to do that, what we did was to select potential mechanisms that exist or are possible in Brazil, following some of the criteria that the biofin approach uses, which is mechanisms capable of generating new revenues or delivering better conservation through improved effectiveness, efficiency, and synergies, reorientation and realigning existing financing sources, and instruments that are capable of avoiding future expenditures. And using these, we selected 25 mechanisms, a big list. I will not discuss all of them, they are here, okay? And after that, we shortlisted, after this big list, we went to a more in-depth analysis for 5 of them. And we chose these 5 instruments using the following criteria. The capacity for their implementation at all federative levels. I mean, it has to be national. I mean, we can only think about a national policy thinking nationally. There are some specific situations that cannot be reproduced in other states. Creating conditions for private investors to participate directly in projects aimed at environmental conservation. These are not exclusive criteria. It's one of them. So if it's good for that, okay, but not necessarily, okay? So if there is a potential for have green businesses, this is something good. And indeed, we found some very important possibilities that actually they are going on in Brazil, even though all of the difficulties. And finally, no need to extra government money. This is a situation which is not optimal. It's not something that we desire. We believe that Brazil has to increase its budget to environmental issues. The public budget for environmental issues has been absolutely reduced, I mean, to a level that is much less than what is at international standards used. We're much below all the Latin American countries in the share, the percentage of expenditures now in environmental issues. Just to give you an idea, at the federal government, the federal expending on environmental issues now is less than 0.1%. It's not less than 1%, it's less than 0.1%. So just to have an idea on how underfunded environmental issues are in Brazil at the present moment. But on the other hand, due to this paranoia, this obsession that the Brazilian elite has, that the state has to be reduced, that the state is wrong, the market is good. So there's no political way at the present moment to expand these expenditures. Let's see what we can do. It's nothing that we agree with, but this is something for the feasibility of the instrument. And the first one, and I think this is a very successful experience that Brazil somehow succeeded, and actually other countries are looking at, is to create criteria for defining the allocation of resources, of budget resources. The ICMS is a VAT kind of instrument, and the state government collects them, and part of it, a quarter of it, has to be, transferred to the municipalities. And the states have the freedom to decide criteria for a quarter of this quarter. Actually, it has changed a little bit now, but it's easier to think a quarter of a quarter is defined by state law. And Paraná State in 1992 started this, followed by Minas Gerais and others, establishing environmental criteria to define how much one specific municipality gets from this budget. It's important to highlight that the total value that will be transferred from the state to the municipalities is defined by a constitution criteria. So the state does not change the volume, the total value. What the ICMS does, the green ICMS does, is to change the way this money will be transferred to municipalities in a way that municipalities start competing among themselves to have better environmental performance, because the better the environmental performance, the more one municipality gets, the less the other gets. It's a way to establish some kind of perception that the way your environmental conditions are, they're going to affect the budget of the municipality. And we have been studying this for a while. This only for the protected area criteria, 44%, about almost half of the criteria related to the existence of conservation units or indigenous lands, what we call protected areas. And we are talking about something like $500,000 per year, which is a lot. I mean, in Brazilian terms, there's no payment for ecosystem service that has this dimension. And I believe that's possibly the biggest payment for ecosystem service in the developing world. And the problem is that it depends on how the state defines. So we have, I think, 17 states out of 27 with existing legislation. Each of them is different. Each of them have different ways to proceed. Some are very good, others are not. And we still have around 10 states without green SMS legislation. Actually, we are working, Professor Castro and myself, in designing one of this legislation for one of these states at the present moment. But the interesting thing is that there is a reaction, and econometrically, we can measure the consequences of this. And what we know is that when there is green ICMS legislation, there is an increase in protected areas, and also the spending on environmental management by the municipal government increases too. It's a very interesting way. But this is only a transfer from, is only connected to the government public administration sphere, I mean, from the state to the municipal. We are not involved in the private sector. One of the biggest possibilities all of the world is payment for ecosystem services, for environmental services, which are agreements between different parts that voluntarily arrange some kind of exchange in a way that, let's say, a rural landowner protects the forests that are in his property, and on the other hand, he gets some money from, let's say, the water company. We have many initiatives at the state level and municipal level, but they're still far from a federal policy on that. We just had recently defined a federal law on payment for environmental services, but this law is somehow empty, it's hollow, in the sense that does not establish where the money is coming from, what is the tax system of that. So it's just a first step, and still very far from reaching the potential we have on that. So the volume of resources is very low. And most of the PES experiences in Brazil are not related to carbon, but to water. And it has to do because water companies, states, they have specific objectives on water, and they know that protecting forests can support and improve the water flows. It has to do with the Catskills experience in New York. Everybody who understands something about this knows this example. And we did some time ago research for the Brazilian Ministry for the Environment, estimating the volume of payment for system services in Brazil. And we, at the time, we estimated that the 2% collection rate in the water and sewage bills would be enough to generate around $300 million per year that could, sponsor a kind of avoiding deforestation RED scheme in the order of 8 million hectares with 100 million tons of CO2 of carbon avoidance. This is something that it's doable, but what are the problems? Uncertainty and the weak capacity to establish environmental policy, because in order to have this working, the people who pays for it needs to understand it. And in the water issue, we have a better understanding from especially urban consumers of water, but not from the largest consumer of water, which is the agricultural sector, which is very against the idea of paying for that. And because of that, they don't have the water. And so now we're going to pay the highest cost, which is not to have the water. So the conflict for water in Brazil is getting more and more evident. David, I don't know if you're aware, we are under a water crisis now, possibly with hydropower cutbacks. And this is because there is a big conflict for water. And so payment for environmental services is a way that we can establish a coordination system through the market in a way that, well, if someone wants to voluntarily to go ahead and to protect more forest in their land than what is required by the legislation, we get some cash back. And this will be paid by the consumers because they prefer to pay for forest conservation than not to have the water or the electricity that comes from the water. But unfortunately, the political institutional situation avoids the possibility of this instrument to go ahead. It's a similar issue with environmental reserve quotas, which is the largest instrument the largest potential we estimated. It has to do with the Brazilian forest law. I suppose that you forest science students are aware of the Brazilian forest legislation that creates this figure of the legal reserve. So every property has to keep some legal reserve. And what is the environmental reserve quota called the CRA market? It's a way that we allow someone who is in deficit to pay for someone that is willing to have a surplus of forest conservation. And it's not related to carbon. Recall this issue of the policy mix. It has to do with simply to follow a rule. Someone can imagine that, well, if I'm also adding forest, I'm also adding carbon, I'm also adding water, I can have a multiple source of resources in a similar way that they've presented in the agriculture. You can imagine a basket of environmental services. In that case, estimates, they depend very much on what is the law and how to implement the law. We still have a huge uncertainty on how to implement this. But value goes from 1 to 20 billion in total volume for 30 years. So it has the potential to generate a considerable amount of resource. Something that we discovered doing our researches on that at first we thought that, well, if there is a national market for CRAS, I mean, if I allow people from different biomes to compensate, let's say I can compensate deficit in the Atlantic forest, in the Brazilian Southeast, with the Amazon forest in the North region. We thought that there would be a lot of investment coming from the south to the north. But I mean, in the Amazon itself, the deficit is so huge that there will be no inter biome movement. Most of the Amazon would require credits from the Amazon to keep themselves. So we strongly believe that it has to be established biome by biome. This is a specific issue I don't have time to discuss here. But the area that with the highest potential for recovery is the Caatinga, is the Northeast, because there is very cheap price for land. So this was a surprise at first. And also some Cerrado, in the northern part of Cerrado, where the opportunity cost of land is lower. Tourism concession is something that is happening. This is something that it's not going as expected due to COVID and all the pandemic. So all the parks have been closed. Tourism has been depressed. But this is something that we strongly believe. And in general terms, I mean, both federal and state governments are having a proper approach. This is something that Brazil has to learn, for example, with the US experience. I mean, the United States National Park System is operating for more than a century with very positive impacts. And we are talking about hundreds of millions of dollars of revenues that can be generated and put back into conservation. The biggest problem here is that usually governments see this as a kind of source of cash, but they do not understand that most of this money has to return to the park, has to return to forest conservation. And see, basically the finance ministry or secretary is very much in favor to have the concession for tourism inside a protected area, but it's not that much in favor of returning this money, investing in the protection of the system, because that's what we need, including to enhance and to have the multiplier working in a proper way. And something which is more polemic, and I think that on this, the science forest, the forestry issue, you can discuss much better, is the issue of forest concessions. And it's something that Brazil is very far behind. We have the Brazilian Serviços Florestais Brasileiro, Brazilian Forest Service, created to develop this. It started in a positive way, but to have forest concessions, especially for timber, it's necessary to have a zero deforestation scenario, because it's extremely dangerous to have forest concessions in a situation where you do not control deforestation. And it's not only because of ecological reasons, because of course, if the system is threatened, you're risking to have much more loss if you allow extraction. So if the system is stable, yes, you can estimate how much you can extract. But if you do not have control of deforestation, ecologically, it's a risk to have further pressure on the forest. But also from economic terms, because if there is deforestation, someone is selling the timber from deforestation, which is depressing the price. And concessions have a different way of costs than, predatory logging, illegal logging, because you have to pay for the concession. You have to pay for this 30, 25-year system. It requires credit. It requires long-term investment. You need to know that if you are saving that hectare of forest to have the timber extracted in 20 years, you have to have the assurance that there will be no deforestation. Otherwise, what's the point? Why am I waiting 20 years to extract this timber if it to be deforested? So there is a big business risk in deforestation for forest concessions. And the only way this sector can be profitable is to stop deforestation. There's also a big potential for non-timber forest concessions. We'll be very shy on that. And indeed, if you talk to the business, the people who are operating the legal forest concessions, they want to have non-timber extraction people gathering, because they help them controlling, monitoring the forest, avoiding scattering and fires and things like that. So it's a big potential that we have not explored so far. Obstacles for that: conflicting interests between resistance by groups that oppose environmental protection, because they think it restricts rural production. And I don't know if David is aware, but there's a big problem now that we have on the indigenous land at the Supreme Court now, the definition of the right of indigenous land. And it's unbelievable for me as an economist to understand that people are saying that the existence of this indigenous land is the reason why Brazil is not developing. So it's essential for Brazilian economic development to reduce indigenous land. But it's exactly what the Brazilian federal government is doing at the present moment. So I think it's a very myopic way to understand the problem. And under this environment, it's very difficult to imagine that people will be investing resources for long-term management. All of these situations are related to long-term conservation. It has long-term investment. Lack of public management capacity to implement and monitor the situation as already expressed, because there is no funding for them. We don't have resources to control deforestation, things like that, to control illegal logging, and etc. So it's a big problem. Institutional uncertainties. The environmental agencies are under pressure, extreme pressure, not only at the federal, but also state levels. All environmental legislation are changing to the worse, not only at the federal, but also at the state level. poor enforcement of environmental policies, and little interest in terms of presenting this problem, because there's no interest at all from the current government to discuss climate change, environmental policies, biodiversity conservation, things like that. So we are missing a big opportunity. So even though we estimated that all of these instruments are feasible, huge potential to expand, but they are extremely underdeveloped. Some can go with some restrictions, such as tourism concessions, maybe forest concessions, but the big pots, which is the carbon and water payment for environmental services, and the CRA market, which requires this legalization of legal reserves. I mean, to make the offset of legal reserves deficit, which, by the way, is fiscally neutral because the government doesn't get any money. It's from one landowner to the other landowner. We are missing these opportunities and all of these possibilities that the world is discovering in this century of how to combine finance and conservation. We are basically wasting and creating a much bigger problems to solve, such as the current water crisis. Thank you very much. So this is the conclusions. Finance mechanisms have this potential. We can generate a lot of money, but the public sector has to have an active role, and weak environmental policy enforcement and institutional uncertainties are big obstacles to go ahead. These are links. I'm going to leave afterwards the PowerPoint with you, link to download all this material and more. And thank you very much.
Thank you, Kadu. It was an excellent talk. The two talks in reality were very complementary, and they are surely thought-provoking. I would like now to pass the word to the members of the panel and initiate the discussion. I don't know if Laszlo and Enrique are there.
Yes. Is there enough time for the discussion?
Sorry?
We end at 4, right?
Yeah, we can end a little bit later if they all agree, but in principle, we say 2 hours.
Can you hear me?
Yes.
Okay. Congratulations, David and Kadu. You need to turn your microphone off. We have a bit of a problem here. Okay, I'm kind of lost now. Wesley, você poderia mudar o cenário? Não estou vendo ninguém das participantes.
But we are listening, we are watching you and listening to you perfectly now. You can go ahead.
Brilliant. Okay, so congratulations on the 2 brilliant talks. It was very interesting, especially in the context that we are just finalizing a large project to submit today about payment for ecosystem services in a part of São Paulo, which has been a big undertaking over the last 10 years. Before doing anything, I would like to play the devil's advocate, and put a question to pose a bit of a debate. For a very long time, the value of ecosystem services considered as externalities in economic terms. Now that we talk about ecosystem services, we are trying to include these benefits that we derive potentially after investment from the environment. In certain cases, especially in an urban context, we talk about ecological disservices. Now, how would an economist consider these disservices? For example, in the case of considering forest conservation in the tropics. It could be Kadu, could be David. So my question is, are you economists, are you including potential economic ecological services which are in actual fact contribute negatively to human well-being?
You mean to have a negative value?
Yes, as a disservice, if you like, not an ecosystem service, but ecosystem disservice, diseases, etc., etc.
Oh yeah, it is. There are many estimates. For example, we think in terms of avoidance. Whenever we talk about cost avoidance, for example, there are some estimates on how much in this just recent literature on in the Amazon and Pantanal biomes, how much we lose in terms of pollution caused by forest fires, in terms of both the issue of waste, lost productivity, but also costs of health treatment. So yes, we can do it. And mostly, I mean, when you estimate climate change, what we're doing is exactly the same. I mean, we're talking about what is disutility in economic terms. I mean, we call utility something that provides a positive impact on well-being, and the negative utility, the disutility, as the opposite on that. So it's not a big problem on that. The main problem is not estimating how much is the social value. The problem is the distance between this social value and the market value, and this market failure in terms of transforming values into prices. And this transformation is the big thing. So we can estimate. I mean, actually, I've just recalled something in terms of diseases caused by pests. I mean, the problem of losing pest controllers, the loss of pollination, things like that. So from a conceptual perspective, it's not a big problem, because any cost that you avoid is a benefit, and any benefit that you're losing is a cost. So we can manage this well. The problem is on how to transform these things into real world issues, how to reduce the gap between the social and the market realities.
Yeah, I think this is crucial, because the whole point of including the value of ecosystem services is to actually bring in those values that were ignored in the past in economic cost-benefit analysis. So therefore, the whole issue revolves around this question of resolving what is as you said, the social value, the ecological value, the biological value, the existence value, and which parts of these and in what form can be monetized.
So let me offer. So I'm not formally an economist. I'm an ecologist, a forest science person. So I have nowhere the expertise that Kadu has. But I see this question come up, and I think it's really an important question, and it's going to begin to capture more and more of the dialogue. I think this idea of disservices and their negative costs. But I think from the ecosystem and forestry point of view, we recognize that, for the example of disease, malaria, for instance, there is, to be sure, some baseline that is naturally occurring malaria that has a negative service to humans. But by and large, the ecologists would argue that the vast amount of negative services, if you will, from things like pests are because of human actions that have modified ecosystems. So like malaria in Hondonia, where I did my dissertation at that time, in the Polano West days, that was the epicenter of malaria. That's not something, that situation was not naturally caused. That was a human caused situation. Other cases of zoonotic diseases, you could argue, have to do with habitat fragmentation more than they do the natural tendency for spillover. And so that, I think, is going to be the kind of big wrestling point, is like, is it genuinely a negative natural ecosystem service?
Thank you. I fully agree that it's one of those contentious issues.
So is Erica coming back? Well, while Erica is not coming back, let me take control of that. So, Henrique, do you have any question, any comment to the guest speakers?
Yeah, me?
Yeah.
Okay. Well, thanks, Heraldo, for the invitation to be here. Are you listening? Are you with me? Okay. First, I'd like to congratulate Heraldo and Erica on behalf of our department. I'm a professor of watershed management here in the university. Well, I'll congratulate our speakers also on their excellent presentation, giving lots of insights, both on the technical modeling aspect of the quantification of the carbon sequestration issues, like David, and also Carlos on the economics and policy instruments that would provide some leeway for future projects and eventually the development of those payment for ecosystem services that we're seeking. My comments as a very humble hydrologist, ag engineer, would be our experience in this issue that goes back to about 20 years when we have devised, when I was during 5 years at the National Water Agency in Brazil, the creation of what we call the Water Provider Program. It's a nationally based program today, the first PES program in Brazil. We have over 100 watersheds or river basins across the country in all regions. And we more or less followed that path that David more or less mentioned, quantification, monitoring, scaling, valuing, and then paying. So that process, we wrote a few scientific papers to show, in some journals here in Brazil and abroad, to show exactly the technical soundness of this process, particularly regarding water quality and quantity, which is the issue that we're talking. And since then, we found that environmental services would be more plausible, more, how could I say, interesting for water users and decision makers because it involves a human being, right? So I prefer, when I write, environmental services instead of ecosystem services because it's more tangible. And this tangibility thing has to do about valuation. And that's what I think the main issue here, because we're not discussing the technical aspects, we're much more in the perception by the society, by decision makers and politicians that these services are worthwhile, are valid, and eventually they could and should be compensated. And so my comments have to do with the experience, in this last 20 years or so, applying the program in helping different basins, river basins, water utility companies, electric sector, more recently the paper and cellulose sector in Brazil to apply themselves this payment for environmental services, as we call it, not only at the public level, which was like not easy to convince our policymakers, because public money would have to pay a private farmer, and they didn't like the idea until we show them that legally it has some binding because of what we call compensating type mechanisms. So the one that sacrifices him or herself would be compensated by an effort that is proportional to the benefit. Like if a farmer controls erosion in his farm by applying different conservation practices, and those practices provide, water quality and quantity benefits downstream for a water user, being a utility company, hydropower sector, or a paper mill, that farmer would have to be compensated proportionally to his generated service. That can be proved, say. So that was the idea of the water provider programs. So the government understood that. In fact, there's some legal aspects in Brazil that provide this, like if cattle in a farm gets a disease, and that cattle has to be killed to avoid the spreading of that disease into our national stock of livestock, that farmer would be compensated by the elimination of his cattle. So that legal framework allowed us 20 years back to convince the federal government to put some seed money and start the first payment for ecosystem services in river basins across the country. So the other thing has to do, and these are also questions. First, I prefer environmental versus ecosystem because it's more tangible for the people, and the people, governments or private sectors, are the ones who will be paying in the end for those environmental services. And the tangibility of the results also has to do with the proper quantification of those services, being carbon, water, regulating, providing services, doesn't matter. We need to prove, by, say, research and other means to break the bottleneck that separate us from policy. So we think about an hourglass. We are in the academia here, and the managers and decision makers are in the other half of the hourglass, and there's a bottleneck in the middle. In order to break that bottleneck of the hourglass, we need to properly quantify the environmental services, to value those services with market, as close as possible to market instruments, and eventually start a payment type system like a circular, what we call a rotating fund that we have applied in irrigation many years ago, we used in this water provider program. So if we do have all those elements of those equations established, we will be much easier to address the issue. What we have done so far, so we developed very simple models that the farmer himself can apply, such as the USLE, Universal Soil Loss Equation, developed at Purdue, where I got my master's and PhD in the National Soil Erosion Lab. So we use that very simple tool to address, the quantification issue regarding erosion abatement in farms and in watersheds. So we showed by monitoring, by modeling, that this or that practice would reduce, 20, 30, or 80% of erosion compared to a baseline condition. So that was the first thing, quantification and monitoring of the environmental services downstream, not only at the farm level, but also at the basin outlet or whatever structure existed there for water abstraction. The second has to do with valuation of those environmental services. For water quantity, we had to go back to Economics 101 and look at Marshall's surplus type model, consumer surplus. So we used the water, tap water type demand curve, elasticity demand curve, and the supply, and we established, using Marshall's very, very old concept of consumer surplus, to establish the gains or the valuation of the improvement of water quantity, say during the drought period, due to increased infiltration in this watershed, providing water that would not exist downstream. For instance, here in Brasília, we have many basins that are under emergency today during the drought. So the irrigators have to shut down their pumps because there's no water for everybody. So valuing the gains of having water is like an opportunity cost at a certain time in the basin, that would be money. So water is money per cubic meter, you name it. So we more or less established the quantification and valuation issue for water quantity, improved infiltration and less runoff. For water quality, during the rain season, we have runoff and sedimentation in those basins. So many times the water utility companies here in Brazil, they have to stop, the water abstraction because the turbidity levels are so high, they cannot treat that water. So the city people, the water use in the city, they don't have water for a few days. So that's a loss, economic loss for both the company, the water utility company, and the water user. So we use like the another economic instrument. So the cost type reduction or cost avoidance for quantifying the improvement in the economics, say, by having cleaner water downstream. So those legal, modeling and economic type instruments, allowed us to convince both the public and the private sector, such as the International Paper Company here in Brazil, to invest themselves, in different programs, namely water. The same eventually could be done with carbon. And another interesting idea recently in a World Bank seminar here in reservoir sedimentation we had, I talked about that many of the practices at the farm level, at the river basin level, that provide environmental services regarding water quality and quantity, both provision and also regulating type services, they also, particularly reforestation and so on, provide carbon sequestration. So the same projects or same practices that are good for water are also good for carbon. And I will go even further. For those like David, I'm not sure if you know, we have 25 million hectares of no-till agriculture in Brazil. The last numbers I found about carbon sequestration under no-till agriculture is 0.5 tons of carbon per hectare per year. If you think about that, the no-till, say a farmer starting no-till in his soybean corn type rotation would take 10 years to reach a steady state type carbon level in his soil. We're talking about 12.5 million tons of carbon, not CO2 equivalent, carbon, incorporated in the soil per year. So in these 10 years will be about 120 million tons of carbon in agriculture. And we're feeding 1 billion people today in the world. So again, we can think about the carbon in the as I think David mentioned, the agroforestry and so on. Agriculture, depending if you're moving from conventional tillage, which loses carbon, to no-till that sequester 0.5 tons of carbon per hectare per year, that's a lot. So what I say is that we could and should be looking at alternative type. If we're looking at a watershed, if we're looking at a state or the country, looking at incorporating both water type services to the carbon, including agricultural systems in those carbon type modelings, and using economic tools with modeling and monitoring to provide the means that the private sector and the public sector, which they have economists as well. And in fact, we convinced Banco do Brasil director here, because he was an economist, and we used this Marshall's type consumer surplus. He said, okay, I understand that. So I did need to finish my argument for the economist of our main bank here understand of the benefits of this. And finally, cost-benefit ratio. I studied about, I think, 10 water provider program projects in Brazil, water-based environmental services here, basins. The average benefit cost ratio in our projects varied between 3 and 8. So for every dollar invested in the basin, we would gain from between $3 and $8 regarding water quality and quantity. I didn't look into carbon in different basins. So I joke with my students that even planting marijuana here in Brazil doesn't give you that return. You see? So that would be also maybe a lesson for us to show the benefits, the economic benefits, the water benefits, the public benefits of, say, improving the environment, be water or carbon. And finally, regarding policy, Brazil has, of course, we are in a sort of a dire situation like the rest of the world, but particularly here. But still, this year, we passed at the federal level our payment for ecosystem or environmental services law, law number 14119 of this year. So we have a law. And that law, you know what it includes? All the instruments, all the services, all the classifications, and it includes green bonds. And green bonds, my fellow colleagues, is probably one of the best tools to provide that leverage that we need to tackle this bottleneck that separates us from the problems to the solutions. Thank you.
All right, Dave, Carlos, you want to make some comments on Henrique talk and comments?
Look, I have some comments, but I think it would be good to have Carlos jump in if he has his.
All right.
Okay. Many important issues raised by Henrique. First of all, in terms of just a clarification, environmental services are human actions. Ecosystem services are provided by nature. So who provides the ecosystem services is nature. And of course, nature is not an economic agent that can charge for it. But human actions affect the availability of ecosystem services. So when we talk about environmental services, we are talking about an human action that has pros and cons and also have costs to implement that. So once someone decides to protect a piece of land, have forest on it, it has an economic cost on it, the opportunity cost of land, and the cost of keeping it, monitoring, avoiding fires and things like that. So this is the economic reason why this economic agent is affordable. It makes sense for this agent to receive a payment for that. So the payment for environmental services is a payment for human actions that protect the ecosystem service. And actually, this is, I think, expressed in the law. But return to what you said. I mean, the main question is why there is no market for water if it is more profitable than marijuana, and everybody knows that there is a market for marijuana. And the question is, again, is this difference between value and prices. And it has to do with something that the law has not decided. Who will pay for that? And yes, if we have a social planner that establishes that externalities are paid for, the polluter user pays principle, only if this is established, then there is a correction for the market failure, and then it has to do not with Marshall, but with Pigou, 100 years ago. It's another century-old economist. And the biggest problem on water is that some, not all of them, but some economic agents are aware of this cost-benefit analysis you provide, and I totally agree with you. And just for, I don't know if you're aware of this, just, Henrique, if you want, I would like to send to you afterwards. This is in our website. This is a report that we produced for the Brazilian Minister for the Environment, estimating a national payment for environmental services in Brazil. And we included a use type equation estimating the benefit in terms of avoiding soil erosion that could happen if we stop it, the deforestation. David, if you want this, I can send it to you afterwards. It's in Portuguese again.
No tem problema.
Okay, no problem. But returning to the problem you raised, the question is that the biggest water consumers are not willing to pay for that. So if you go into the national water accounts, I mean, something very positive we have now is the Brazilian National Statistics Office, IBGE, is producing their water accounts. And it shows that the biggest user is the agricultural sector. And the agricultural sector is not willing to pay for that. Even though some providers for urban consumers are aware of this and are starting to implement not only to the Produtor de Águas, call it the Water Provider Program, Baiana, but also the Oasis Program and other programs. And we studied this under the subnational level. The biggest problem remains who wants to pay for that. And not because it exists a law. And they return to another law, which is law, I forgot the number, the law that created the National Protected Areas, the SNUC law, establishing Article 47, that protected areas that are protecting water for consumption, they have to receive from the consumers. In Brasília, the National University of Brasília gets water from the Parque Nacional de Brasília, the National Brasília Park, and does not pay for that. And the park does not receive a penny for the water it provides. There is a law saying that, establishing clearly. Article 47 says it's not something that is theoretical. It says explicitly, if there is water being consumed from a national park, such as Brasília National Park, it has to pay for. But there's somehow the political situation, the circumstances blocked this. And that's the biggest problem. So even though from a social planner perspective, yes, it makes a lot of sense to establish payment for environmental services. I have only one question about the ANA, the Brazilian federal system, which pays for the wall. It's the way how you estimate for the area to receive. In the ANA model, at the federal level, it pays for the entire property, while at the OASIS program that we worked for, we paid only for the forest area. And the biggest problem of paying, if you want to have to pay for the entire property, is that the volume of resources that you have to pay has to be much bigger. So the more area you pay for water conservation, more you have to pay. And so you need to raise more money. And then we return to the biggest problem, regional problem. Who pays for that? And unfortunately, the national law does not establish this as well, including establish something very bizarre. In the national law for payment for ecosystem says that, well, we can get the money from donors. I cannot have a national policy for anything based on donors. It's something that it's economically doesn't make sense because it's something that I can't control. So that I can't assure for the sustainability, the financial sustainability of this program. But the principle is absolutely right. I totally agree with Henrique. The problem is why it's happening. And the biggest evidence is that the problem exists and has worsened, is that we are facing the worst water crisis in the South-Southwest with huge impacts on water resources, which in Brazil has a significant impact on hydropower and electricity without doing anything at all. At the same time, we're establishing more incentives for the agricultural production, which is the sector that is consuming the more and using the numbers from the IBGE, producing the least with the water. If you look into how much value is added by the consumption of a cubic meter of water, the economic use of minimum return is agriculture. And we are not doing anything to arrange this. Mm-hmm. We end up, it's similar to your example, Dave, on carbon. We have such a big possibility, but we are wasting it away. And the consequences we are paying for that.
Mm-hmm. Great, Carlos. Let me weigh in on some of the points you made, Enrique. And without being specific, it's just the kind of what I've taken from what your comments were. One is this issue of the quantification and measurement. So I emphasize that we can monitor it, we can map it, we can measure it. That means it can be verified, and that means it can be reported. And that means in principle, you can create a financial instrument out of it, okay? Without that, it's established by many folks that if you can't quantify it, it's very dubious to create a financial instrument that can be traded on a market. That's a very carbon financial market way of thinking about it. And it kind of assumes that there are these trading platforms that then trade verified, quantifiable financial instruments. That makes a lot of sense, but it's also true, and we found this when I worked on the Chicago Climate Exchange. I was part of the Chicago Climate Exchange as a faculty member from MSU. MSU was a member. We found ourselves, and I was on the committee that established the protocols for forests and some of the other offsets. And what we were finding is that it was very difficult to quantify a lot of things. The soil conservation number that you gave is a great example. That's not really born from any kind of explicit quantification or knowledge. It's kind of almost a rule of thumb kind of number. We found that in order to motivate and activate participation, we had to back off a little bit from the explicit measurement and quantification. And instead, if you look closely at the Chicago Climate Exchange protocols and guidelines, some of those get really close to just indexes. But the truth is that you could run a market, it looks like, if you had a mutually agreed upon number for a hectare of tropical rainforest conservation, rather than actually having to measure it and report it. That if the market accepted that number, it becomes the standard by which, you know, you can certify an instrument and trade with that number. But that's almost heretical in the discussions today, particularly the science discussions, where the science supporting discussions say, we have to have full carbon accounting, we have to actually measure it. But as I understand things, when I look at this kind of is grounded in the principle of whether you're practice-based or performance-based. And you see a lot of environmental, market-oriented environmental activities around practice-based. The most obvious one to me that we've used at Michigan State University is the LEED certification for buildings. You go through a series of steps and there's a checklist, and if you do those practices, you get the credit. Nobody measures whether you actually saved energy or not. That can be quite useful and acceptable. The question is whether we would do that in forestry carbon or not is really up in the air. And I think it's controversial. Instead, we go to these performance-based measurements, right? Although there are ways around that, particularly for soils and some other kind of things. So I think there's a lot of room to innovate and think further. And I was struck by what Carlos said about the one example he gave where the forest itself, I interpret it as an area, got some credit for conservation because it created a basket, as you said, of ecosystem or environmental services. Not just the carbon, you assume some carbon has been conserved, but also some biodiversity, something else maybe related to water, et cetera. If you go away from performance-based into practice-based, you can start to build those baskets, I think. I think there's a lot of room for innovation. And what's happening in the US in the voluntary markets, which I agree with Carlos, the voluntary markets are a bit less real because they're not regulated, you know. They're not compliance markets, but they're there. And what's happening is they're becoming these experimental platforms, and they're promoting very much what they don't call them baskets, they call them stacked. So you have a project that has carbon, but it's also stacked with something else like water or wildlife or something like that. A lot of times it's wildlife. In fact, I worked on a project in Africa, the Rukinga project, a RED project, where it was actually a wildlife project first to protect a habitat corridor that they put carbon on top of it. Carbon was the only thing that was quantified. The wildlife habitat was just area-based. So it actually leveraged the money from the carbon sequestration to protect wildlife habitat. That was the real goal. That was very effective. So that's something that I got out of that. The other is this idea of having it really relate to human needs. In developing countries where I work, that means farmers need it to tie to incomes. And there's been some interesting, really new work from Roger Leakey, who's talking about land maxing approaches. And so what he did was, he said, look, our traditional approaches to conservation agriculture or conservation forestry has been based around this land sharing versus land sparing model. You know, you share the land with some other kind of agricultural productive practice, or you spare it. You put up In other words, the former is kind of like agroforestry, or you put in a conservation piece and an agricultural piece. That's like the Brazilian Amazon model right now. You have to conserve some forest on your farm. That's a land sharing kind of, or land sparing kind of approach. And what he says is they don't work. And they don't work because they don't integrate the income piece into that for the farmer. And so his land maxing model builds on his multifunctional agriculture model, which is kind of the old conservation agriculture, land sharing, land sparing, but builds in important premiums for incomes in the model. He has a piece in Nature Food last year that elaborates on that. You should look at that. Everybody should look at that. I think it's very interesting. So bringing the income piece in is really, really critical. Yeah. So just some observations from what you said, Enrique.
All right. So I'm back. I have some questions. I don't know if you have anything else to mention, Laszlo and Enrique. If you don't, so I have some comments and some questions from YouTubers. We are kind of advanced in our time, but I think you can quickly read them and ask some questions to the guests, if you don't mind.
Yeah, if I may have a quick comment on this,
go ahead.
Maybe I was not contributed well. First of all, we are paying farmers for many years, for 10 years, here in Brasília, right here where I am. And the revenues they have so far, maybe it's not much, but it's significant. They can buy, say, a new implement, a new farm implement almost every year from what they gain. These are small farms, they're receiving a check every year. Okay, and they get all the practices cost-free. You see, this is here, 30 kilometers from here. About the irrigation thing, okay, think about the opportunity cost. If you don't have water, these irrigators here in the Pipiripau River Basin, they are probably now without, they cannot irrigate the time they need. So they need to ration water because they're not first time, they are the second or third priority. Humans first, and then later agriculture and cattle. So if they write down the losses that they have by not irrigating their irrigated land during, say, a month, put together, and then eventually they could think of, okay, so if I pay, say, 20% of what I lose as far as revenue for not having water, that would be good for me because I pay 20, but I get 100. Say having more water because of more infiltration during the rainy season, and there's a lag time between groundwater and surface water. So you have more what we call the base flow during, say, the dry season than we would have without infiltration in the upper basin. So irrigators would gain. So this accountability that David is mentioning, we're doing with models. With Stanford, we developed the INVEST model that has a sediment and water yield components, and it's being used by farmers and NGOs around here in Brazil, like WWF and TNC. We're working together. Even the Rio Doce Basin that was impacted by the Mariana disaster a couple of years ago, we're using the INVEST model there exactly to quantify the environmental services provided by farmers in this secondary basins of the Rio Doce. So we're using it. And then, of course, INVEST has some economic instruments, particularly in sedimentation, embedded in the model already. So that's what the thing is. And the last thing, I agree with David, that we need to think about a basket, like this land maxing thing of using all the possible ecosystem, environmental, you name it, of course, if we are, doing something from a baseline, so I think it's environmental. That's what I meant. and the performance-based mechanisms like produtor de água, we pay based on the performance. If erosion is maxed, is minimized, the farmer receives more. If infiltration is maximum, more. If not much, less. And there's a threshold value. If it does not reach, he's not paid anything. And that's, we learned this from the Economic Research Service of the USDA in the US. The performance-based mechanisms are much better than the whatever the participant just participating gets paid. It's not going to improve anything. So we need this performance-based mechanism. That's why we created the Produtor de Água with that particular approach. So I think it's clear. I have some documents that with WWF in Água Brasil program, that was a country-based program. We published some books for farmers and decision makers with all those cost-benefit analysis of different basins in Brazil, and I can. I think there's an English version of that, so I could provide that to you if you want. So the idea is we are already doing this with water. We change it like river, what we call river basin committee, one of the largest in Brazil, the Piracicaba Basin in Brazil, PCJ, has passed, 10 years ago, a tax from water charge from their water users, and they're giving back to farmers, giving back in the sense of payment for environmental services in their basin for 10 years. We passed just the beginning of this year in Distrito Federal, where I am, a policy that also has a water tariff in the water bill in every home. 0.5% of all the revenue of our city, Brasilia, goes to payment for our environmental services programs. So it's already on. So and we now, with the federal law, with the green bond, companies being allowed to trade and buy services from farmers directly and sell them in the market. That's what we're looking at. We have the instruments, we have everything. I think we need to start. That's the idea. Heraldo, back to you.
All right, I'm back. Anyway, you want to make any further comment, Dave or Carlos, on what he just said? If you don't, I'm gonna I'm gonna read some comments from the YouTube in respect to our YouTube viewers or watchers. So let me just quickly make some comments. We have about 45 viewers watching our presentation today, and thank you very much, Carlos. Thank you very much, David, for your talk and your presentation. Also, Henrique and Laszlo for your comments and questions related to the presentations. And Fatima Brito just made a comment saying that the Brazilian government has encouraged devastation rather than environmental conservation. Okay, Fatima, just a comment, just reporting it over here. So Camila said that is enjoying this presentation. She's thank you very much, Carlos and Dave, for your talks, and she really said that it was really great to see, to watch it. So there is a question now from Renato Santos. He's asking, how can you measure the political impacts in the environment agenda without systematic data provided by the federal government? I think that's a hard question. Maybe is addressed to Carlos, right? How can you measure political impact in the environmental agenda? Wow. Without any data provided by the government. That's hard, right? Anyway, you want to say something, Carlos?
One way is to measure, we cannot measure it directly, but one possibility is to measure between how much we are wasting from that. So, I mean, from difference that what could we be getting? How much we could profit if a different approach has been considered. And just to give you an example, how much does it cost to have a water crisis at the scale we are facing now? David, with you.
Yeah, that's a good comment. Another interpretation of that question would be one that I think is really tricky, but important, and that is, if I were to rephrase it, I don't know if this is right, but you might be asking how do you evaluate the government policy actions on its effect on the forest environment, say with respect to carbon. So, in other words, this is a question of attribution that is important in terms of the carbon under RED in some of these kinds of programs. So the downturn in deforestation rates in Brazil that did occur was tremendous. It was spectacular. That occurred over a 10-year period before it's now going back up. One would immediately say that that's due to government policy. But we have no real hard evidence that it was. It seems obvious, but it's a very tricky thing to attribute the change in emissions in the forest sector to specific policies that are made at the national level. And that attribution task is really a challenge for us, I think, how to make those kinds of attributes. And if it was, how much of the downturn was related to that versus something external, like a financial situation or an economic situation. So I think that's a really good question in that context. How do you measure the impact of policy on the forest environment with respect to carbon and RED plus, for instance? And of course, the opposite is true too. How can you attribute an increase to government policy quantitatively? And then the second part of that is you really have to have some government statistics and data. So if those data become scarce for one reason or another, that it will be difficult.
Yeah, that's it. Anyway, I have a question actually to you, Dave, and probably to Carlos as well. We have seen in Brazil and probably in many parts of the world the forest stewardship. It adds value to the timber itself, because people that have this forest stewardship, they can get more money, the timber that they're selling. But in the meantime, you have to pay a lot for the certification, all those consultants, all those stuff that at the end, the final price, it doesn't compensate much compared with the price without any stewardship. Anyway, how do you see this kind of problem, this kind of issue for the ecosystem service as well? For instance, you need to have like you said, you need to measure, you need to monitor, you need to map, and then you need to accreditate it. Otherwise, you cannot sell it, right? And then you start adding value on the mean, like there are a lot of expenses on the mean estimation, and then the final price is gonna be lower. So how do you see that in the ecosystem services?
So that's a good question. I think Carlos will have the final word on it. But sometimes we've referred to this in a way as consumer compliant markets. So you were used to thinking about carbon markets as being compulsory markets or compliant markets, as Carlos pointed out in his presentation, set by government regulations or government restrictions on something in the environment. But there's been a sense that there's oftentimes very powerful incentives to change your forest management practices based on what the consumers want. So we call this consumer compliant markets. I think there is evidence that some of that has happened. The biggest pulp and paper company in Asia came under really, really heavy scrutiny, and their brand was diminished by their practices in unsustainable forestry. And they kind of thought, well, it was for pulp and paper, so who cares? But they did change their practices to be more consumer ready and compliant. And you see that in some of the agricultural products markets, like Hershey's chocolate is doing more shade cocoa because consumers will buy it. And there is a sense that in some markets, several markets, the premium for the stewardship or the environmental benefits is better. And the consumer will buy it. And it may be more powerful even than governments, but I'd let Carlos comment on that. But so the other way to think about this is how do you add the social benefits? So now in red, for instance, there's this thing called social safeguards. So you could store a lot of carbon in a simple plantation that's automated and has no employees. But under the social safeguards, that would be kind of discouraged. You'd want to have natural regeneration or mixed species, and you'd have to have good employment practices and all that. And so that one would assume would be have a premium on it too, although I've seen less evidence of that. We often have a term for that too. We call it charismatic carbon because it's more cool, more socially acceptable carbon. Yeah. So I think that's a good question.
I think, David, you already answered everything. Just to rephrase what you said, Heraldo. We are talking about the same good or different goods. If you treat, sustainable management forestry product with to the indigenous rights and etc. as the same product as timber that has been extracted illegally, possibly with violence, if you consider both as the same good, as a commodity, so you pay for the minimum price, whatever, doesn't matter. But if you make a market distinction between the two of them, I love this charismatic carbon. They incorporate this to my own talks now. If you have a charismatic timber and non-charismatic timber, if they're different goods, they have different prices. And actually, what FSC and other certification does. Mm-hmm. And not only we need to have private consumers, but also governments to do public procurement, only buying the correct timber, only the charismatic product. The same for agricultural products. I mean, if you are purchasing organic food, that will be much better for your health. Are you willing to pay the same price that are getting something which is full of agrochemicals that might be, harmful for your health? No, they are different products. So the solution is, we are talking about two different goods, even though they have some similarities. And this is only possible if we work in markets. And it has something which is part is voluntary. The voluntary side of the market is important. Environmental education, campaigning, etc., but also regulation. Stopping, forbidding to purchase this kind of thing. That's the only way that, certified timber will have a better financial performance than illegal timber. It's the only possibility is that we are not talking about the same thing. We are talking about two different things.
Yeah, right. So I have, I think, two more questions over here. One from Ana Paula. Ana Paula is asking, she is actually concerned with developing countries' payment for environmental services is important to improve conservation and management of natural resources. But how long should we have make those payments? Temporarily, permanently? You want to make any comment, Carlos?
That's simple. If you live in a house, for how long you have to pay for the rental of it? If you
always live there.
For how long we stay in the planet?
Exactly.
So another look at that question is that in forestry, Heraldo, is that there is a term called permanence. And in fact, the intervention you make, say a tree planting project, has to be permanent. In fact, for the regulatory requirements in California cap and trade say that forest has to be certified, has to be in place for 100 years. Because we know that if you put in a tree planting for 5 years and then convert it to pineapple or sugarcane, there's nothing gained at all. It's all lost. So this is a special burden that forestry has that, say, industrial gases don't, like methane. If you flare methane or use methane for 5 years and then stop your project, you're still okay. You're still okay. You reduce the GHG emissions from methane to the atmosphere. But if you stop the project in forestry and don't have permanence, you got a big problem. So that's one of the reasons why forestry credits are low, because the risk of conversion or reversals, as they're called, is really quite high. And the longer you have to keep it, the higher that risk of happening is there. So it's a special challenge we have in forestry.
All right. So one more question from Alex Brazil. He's asking, he's actually made a comment and then a question. There aren't many reforestation or afforestation projects in Vera platform. How do you see this matter? Are there any barrier for it, or?
There's the question, Araldo, is there are not very many forest.
There are not many reforestation projects in the Vera. Is this Vera platform?
Vera, yeah, sure. It used to be VCS, and it still is the VCS standard. It's called Verified Carbon Standard.
He's kind of affirming that there are not many reforestation projects. And why that? Why that happened?
There's two reasons. One is the risk issue that I mentioned before, that the risk brings the price down, and also risk is by itself something that investors want to avoid. We have not done a lot of good work on building financial instruments based on risk. I did some work with the Chicago Climate Exchange. We tried to do that, where you could build in the risk into the financial instrument, or have a risk offset measure from another provider. But basically, the risk was just absorbed by lowering the price of the financial instrument. And so that's discouraging. The other is that forestry projects like tree planting are offsets. They're not reducing emissions directly. They're actually offsetting emissions. And most of the markets, like California, limit the amount of offsets that can come into the trading, because they need to still incentivize lowering overall emissions. And if you flood those markets with a lot of offsets, then overall emissions don't come down. There's a criticism out there about offsets in that regard. Everybody's talking about net carbon zero or net zero carbon. What that means is that you can have a lot of offsets and get to your goals. And so there's some criticism about whether how much of that we should actually do. So that's another challenge we have in forestry, is that it's that kind of offset. But those are typically the two reasons why they're low. The other is that the Vera markets are still growing. They just started, particularly in the U.S. And they have some of their own problems. The voluntary markets that Carlos talked about earlier.
Right. So there is another question, probably that's a very trick for me. I don't know for you guys, but academically, there are differences between the service valuing and service pricing.
Mm-hmm.
That does not work for society. Would we educate people by pricing services for conservation? That's a question.
I think I did not understand properly what is the meaning of the question. But I mean, these are two different things, values and prices. Something has value if it's important. Let's say Van Gogh's picture, a painting by Van Gogh. What was the price market when he was alive? Zero. Nobody would like to buy it, but it had value. And now, what is the value of Van Gogh? So market prices are something that are defined by the interaction of people in a social environment, which is the market. The value is important. So things may have a lot of value, but no prices. Maybe in the future, the example that David was talking about, the offsets, maybe, and then the volume of carbon is the one that goes down. So it's the nature of prices. And just to finish, a stock market only exists because people think that prices are different from values. I only going to buy a share, a bond, if I believe that the value of it is higher than its price. And someone is selling to me because this person believes that the price is higher than the value. So these things are going all the time very unstable. People believe that these things are stable over time.
Right.
Main difference that, prices depend on the specific circumstances of the market, because it's objective. How much does it cost? A barrel of oil today, a ton of iron, whatever. It's what the market gives. What is the value of it? It's a different question.
Right.
All right. So just a quick last comment from Alex Brazil again. He's saying that people pay for higher gas and energy prices because they have no choices. Regular people have no idea about environmental services. Yeah, just a comment.
I would just say, great comment from my friend Alex Brazil, if it's the same guy.
And
if I may add to that, Heraldo.
Go ahead.
I have to leave in a moment, but they do pay for a very high energy price and water price, because most of the people do not understand that the environmental and hydrological impacts and negative externalities that exist, like silting of reservoirs, not having enough water, reservoir failures like we had in the Distrito Federal 2 years ago, that is caused by humans, and eventually not addressing the issues correctly. So if we do use adaptation measures, some mitigation measures wisely, and invest in accountable projects like the ones I've mentioned here in Brazil and overseas that we have already started in different countries, Produtor de Água, we would see those prices going down, and the perception of society will improve, providing further means to address those issues more efficiently in the future.
So, Erica, you want to take control of the final thoughts? And
if the questions are over, we can thank our speakers, the members of the panel, and that's it.
Yeah, I would say, what is David? Is David here? Okay, David's here still, and Carlos as well. So I just want to say thank you, Dave. Thank you, Carlos, again. Thank you, Erica, for all your organization and your work done for get it done with this Colloquium done. And also Laszlo and Ricky, thank you very much for your participation. And Wesley as well. Thank you, Wesley, for your technical support in this meeting.
Great. Thank you, everyone.
Carlos, you want to say final words? Then we are done.
My final word, just thank you. And I enjoyed very much, especially what David said, but also the comments from the panel. It was a big pleasure to be with you.
All right.
Thank you.
I would just say thank you, Geraldo and Erica, for setting this up and for inviting me, because I really enjoyed this. Carlos's talk was one of the best I've heard since I've been locked down on COVID. and I learned a lot, and it was great, how complimentary I think it turned out to be. So that's probably because of your engineering rather than